Hey everybody, this is Larry. This is day 24 of the Leetcode Daily Challenge. Hit the like button, subscribe, and join me on Discord. Let me know what you think about this poem today. Quick injury update, as people who might have, if you don't know, watch my video yesterday. Basically, today's my rest day anyway, so I wasn't going to do much. So I just slept a lot and eat a lot, which is great. My one day a week that I get to do that. But my ankle is still a bit swollen, but I do have a brace. I'm not wearing it now because that's why it's here. I have to kind of give it a little bit of a rest, but I was doing some walking. I actually ended up doing, like 5 miles today walking. So, just modest walking around New York City things, really. We'll see. My knee is also a little bit banged up. We'll have to test tomorrow to see if I could do tomorrow's workout, but today is fine, I think. And I just had a very good cookie from a Chinese bakery, so I'm a little bit sugared up. I need some water, honestly. So I paused to get water. My apologies. Okay, but let's take a look at today's poem. 3043. Find the length of the longest common prefix. You're given two array, so we're doing string poems lately, I suppose. But you're given two string with positive integers, R1 and R2. Array 1 and array 2. Prefix of a positive integer is formed by one or more digits. 1, 2, 3 is a prefix of 1, 2, 3, 4, 5. Okay. Common prefix of two integers is just a common prefix. I guess that makes sense. Isn't there a 5655? And I guess 565 is also a common prefix, but 5655 is, I guess, the longest common prefix. In any case, it doesn't matter. You need to find, the length of the longest one between all of them. Okay. Where x is beyond. Yeah, I think this is, I think, first of all, let me take a quick second to make sure I'm reading it correctly. But it seems like you can just do what we had yesterday, right? We have a try yesterday. Again, this is a very basic data structure concept, right? So I'm not going to go over it too deeply, but you can think about it as a tree, and it is pronounced try, in case you're wondering. I don't ask me why. Don't ask me why. It's called a try. There's some rhyme to it, but I don't get how. I don't know. It's time to say goodbye to the song. Okay, that's terrible. Anyway, but basically, it's a tree where you have some nodes and very tree things, but where the edge denotes a transition that is in the string problem, it will be the alphabet. In this one, maybe it's a digit. So maybe this is an A, this is a B, this is an F, there's no D or E or whatever. So then that means that there's no node going from the root, and this is the root node. And here, sometimes you store stuff like whether this is the end of a node or end of a word or something. So, there are things you can do with it, but that's basically the visualization for a try as a data structure. And good thing is that it does allow you to get prefixes very cheaply in general. So that's basically what we want to do here. And we just have to return the longest common prefix. So we can definitely but put everything into a try on one side and then just look it up on the other. Technically speaking, like in problems like this, there is a micro optimization about choosing try 1 or array 1 to put into the try, or array 2 to put in the try. For now, it probably doesn't matter that much. It's not a big deal, but you can think about it that way. Usually, it's like the number of things, number of items. But in this case, every digit is one traversal of an edge. So technically, it'll be the sum of all the number of digits in one of the arrays. But like I said, it doesn't usually fact that much, so we won't worry about it. And we're gonna write the try from scratch, right? Same as yesterday. The thing with these try is that sometimes you do want something a little bit different, but this is how I usually start it off. As the thing. You might even get away with So edges is a lookup table containing the edges, and root is just the root of the tree, right? Which in this case is a try. You could, everything else is mix and match, and of course you could. A lot of people do try to inline these things into its own object. I don't know how I feel about it, to be honest, but I don't know. Usually it's not a big deal, but Leetcode sometimes in the past have made it so that try solutions has to be more efficient than another language because Leetcode is sometimes incompetent or just don't care about Python, which maybe to me is the same thing. In any case, yeah, so then now we can say for x in array 1, we can just say add x, right? And here we'll just convert it to the string because we're a little bit lazy, but it doesn't even matter that much, right? So then we have an add function and the x function, right? And maybe s for string, maybe that's a little bit better. Yeah, we start at the root and then we traverse down the character at a time, right? So if c not in current.edges, then we just create a new edge because here we're adding, right? So that's why if it doesn't exist, then we create a new edge. This is wrong. I have to see, right? And then we just traverse afterwards. So we ensure that it always exists after this. And yeah, in theory, like now we can do something like is equal to true or something like this. But you don't even need this because every node that exists somehow. So we don't have to do this. And then now just for x in array 2, we go to that maybe source string of x, and then maybe this gives us a value which is the longest given this current x. So then maybe I don't know, v is equal to this, and then longest is equal to max longest v or something like this, and we can return longest, and we start it at 0. And that's pretty much it, the idea. Of course we have to implement search, which is actually going to look a lot similar to this, to the other traversal of the try, except for that so maybe we have a count, right, for how many things we match. If c not in current.edges, then we return false, or return count, sorry. And then otherwise we increment count and we go down one deeper. So that's pretty much it. We also want to maybe return count afterwards. And then yeah, that should be it. Maybe I'm off by 1, but which happens a lot. But that looks good for at least for the input. I'm a little bit YOLO, so let's give it a quick submit. Yeah, it looks pretty Gucci. Yeah, what did I do before? Curious. Yeah, okay, this is just me hacking it. Maybe that's because this isn't a contest. On contest code is, I think I probably do. Yeah, okay, contest code stuff. Are the constraints that slow? No, they're not. Oh, I mean, I guess they are, huh? Yeah, I mean, so this is a try way of doing it, and I recommend it. The reason why I guess I missed this a little bit is that I saw 10 today, and I kind of just forgot about it. But actually, it just means that there are at most 10 digits. So it's not that bad if you had done the set thing. But, if you're not in a contest, don't worry about it and just try. No pun intended, but maybe a little bit now. Try your best and practice your tries. But yeah, what's the complexity here, right? For each character, if you will, or each digit in every number combined, we just do one add operation that does one traversal, and also the same for the array 2. So this is just going to be n plus m, where n is the total sum number of digits in array 1, and m is equal to the total sum number of digits in array 2. And yeah, and that's going to be lower bound. And that is time and space as well. And that's all I have for this one. Let me know what you think. Thanks for watching. Learn, try, stay good, stay healthy, to good mental health. Have a great rest of the week, everybody. I'll see y'all later. Take care. Bye bye.